Hi, folks. As people start coming into the meeting, we'll give it about a minute so folks can get in. But I want to remind everybody that this is being recorded. And so if you know somebody who wasn't able to make it and registered, or if this is anything you want to look back to, this will be available down the road. If you registered for this, you'll be emailed when the recording of this is turned around, hopefully in week and a half is the timeline it'll be, but it will be available for folks. And we will dedicate time of this talk towards a question and answer session. We will be monitoring those. So if you, not in the comments, but in the question and answer portion, if you have a question, you can write it out there as it comes to you, and they'll stack up there, and we'll give priority to those questions in that Q&A section and dedicate as much time as we have available to talk about those questions or spend more time going over any aspect folks find interesting or really want to learn a bit more of. So I want to, once again, thanks folks for taking the time, tuning in and joining this talk that's focused around trying to identify and investigate some of the benefits of cover crops into an organic vegetable system. And this being done at Rodale Institute's California Organic Center. So we're dealing with a bit of advantages and a few additional challenges that come from growing vegetables in California. Now, throughout this talk, and if you're familiar with the mission of the Rodale Institute, the term regenerative agriculture might be something you're a little bit familiar with or something you've heard in the past. And I do want to take a little bit of time to talk about this. And that can be because it's one of those concepts that isn't as well defined. You could talk to three different people and get three different definitions on what regenerative agriculture is. And this is a definition that I like and prefer. It's pretty general, but all encompassing. It's a holistic approach that isn't a set of practices. It's a continuously evolving and improving set of practices that are looking at not just the way the plants are growing itself, those environmental aspects, but social and economic measurements as well. Really, it comes down to increasing soil health, promoting biodiversity, and an agriculture to produce a more nutritious food at a profitable way. And if you're on a regenerative farm, or if you're doing something practicing regenerative agriculture, that's going to usually entail a lot of practices centered around soil health. So reducing, or in some cases, you're able to completely eliminate the use of tillage, so any plowing or disking of the soil. A regenerative system is going to have continuous living roots, things like cover crops, things like intercrops or living mulches. You've always got something green and you're almost never seeing the bare soil. Regenerative agriculture is often a elimination of the reliance on a lot of synthetic pesticides and fertilizers. You're finding natural means of fertilizing your vegetables and pest control. And one of the tenets that I mentioned earlier that I think is most emblematic is a promotion of biodiversity, whether it be there's a lot of plants growing, you've got a lot of invertebrates in there, and by virtue of having healthy soil, you've got a very biodiverse amount of soil. And the work that I'm going to be talking about today is, I mentioned, is the Rodale Institute's California Organic Center, which is located at the McGrath Family Farms. This is one of the more picturesque views from working in the field. You can see the mountains that are actually snow capped a little bit during a few months out of the year. And if from this view, I could turn the camera around 180 degrees behind where that picture is taken, if you go about 8 miles, we're by the ocean. So a very unique place to be doing agriculture. And California is a very large state with a lot of agriculture throughout it. So the California Organic Center is located in Ventura County, so Southern California. I say it's about an hour further north of anything someone would consider that greater Los Angeles area. And this is a really cool map that the county put together looking at some really general picture of agriculture. And agriculture in Ventura County is by far the biggest industry. Now, the yellow star towards the middle of the map, it shows where the center is. And this map is very interesting because it shows you kind of the breakdown of the different commodities and gives you an idea of what kind of a production area you see. Towards the upper part of the map, it's a lot of oranges, yellows, and greens. A lot of that is orchard operations. Avocados, lemons, and other citrus are really big in the area. And as you go further south, it kind of is a flat valley where we're located towards the ocean. That's an incredibly diverse landscape with a lot of vegetables. The red that you see there are strawberries, which is the biggest revenue generating fruit or vegetable in the area. But those blues is an incredible mix of things like your lettuces, tomatoes, peppers. You could be driving down to see artichoke field on one side and a field of green onions on the other. It just gives you an idea to the incredible amount of productivity and diversity of agriculture that is grown in this area. And this is the area in Ventura County where our center is trying to serve. And these are our main goals, if you would say, what is the point and what is the mission of the California Organic Center? And I want to note that is Phil McGrath, the farm owner, looking very intimidating in this picture. But what we're trying to do is conduct research trials that are centered around the unique challenges that California growers are facing. So we're like a research institution or like a grower field where they're testing something new. We have these trials set up where we can monitor what kind of things are growing in California and what are the obstacles or what are the potential benefits they can see from growing under organic and regenerative practices. And a big part of this research is centered around supporting California's growers. We're not just doing these experiments, writing a report, and it's something that sticks in a binder for the rest of time. We are very deliberate in these projects being applied and being communicated with growers, hosting events, hosting field days, getting out into the farming community, sharing these results. So maybe the grower can take exactly what we did, but the bits and pieces, the practices that we found work, they can apply to their own system to promote sustainability with the ultimate goal to increase the amount of acreage in California that's dedicated towards organic and regenerative agriculture. Now, a lot of what I'm going to be talking about, as you probably guess from the title, is the integration of cover crops if you're a California vegetable grower. And one unique challenge of integrating cover crops as a California grower is you're taking some portion of your field or some time of your season out of production. And what I mean by that, this is another nice map, this one showing a timeline of when in the county agricultural products are being harvested. And I grew up in the Midwest, so you had a couple months in the winter where there's not going to be a whole lot going on your farm field. But as you can see here, there's really no stopping point. Some vegetables are harvested in the summer and fall, but then a lot of growers will turn around and start harvesting their winter vegetables, things like lettuces or celery or broccoli. And so any amount of time dedicated toward producing a cover crop, that grower is not putting in one of these cash crops that would be generating revenue. So to incentivize and to help growers understand why a cover crop can be something beneficial, we want to highlight some of the advantages towards growing it. And when you're producing a cover crop in a no-till system, so it's not growing a cover crop and disking it in, mixing the soil, if you're trying to do it with minimal or no tillage, the termination of that cover crop can be incredibly difficult. You spend all your time growing something, and then when you want it to die, that's of course when those cover crops are stubborn and not wanting to die off. But what we've found is that there's a set of practices that can really do the trick well. See if the video will play for me. So what you saw there is a cover crop that we had grown here, and being pulled behind that red implement is a roller crimper, which is something that if you're familiar with some of the work that Rodale Institute has done in the past, this is a tool that's been very instrumental in creating these no-till cover crop terminating practices. So that cover crop that you saw was standing up, and it was pretty high. I think we were measuring it. It was well over 5 feet and pretty dense. And that red implement is hollow, so it's filled with water. So that's an incredible amount of weight. And when it's pushed down, it's not digging into the soil, but instead it's all that weight is on those beveled edges that you saw there that crimp down. And so where the cover crop is coming out of the soil surface, crimps it down, kills it, and lays it flat to allow for a really nice cover on the soil surface. And when that's successfully terminated, you can get a really nice coverage. So this is just on the left-hand side, a picture showing that cover crop once it's terminated, and the picture on the right is a bit closer up where I kind of cut a hole in the thatch to give you an idea of how thick that coverage is. So that mat, after drying out there for a couple of weeks, really does a good job physically covering the surface. And what we were trying to look at is can this create as the residue of that cover crop, a ideal weed suppression for this mulch. If you talk to any organic grower in Southern California, probably in a lot of other places, one of the biggest challenges can be the control of weeds in your vegetable production system. There's, depending on who you ask, very few or none at all effective organic herbicides, and so an incredible amount of money or labor is dedicated toward physically removing the weeds, going out there with crews and digging up the weeds to create that environment that's nice. But if you can grow this cover crop and have it act as a weed barrier, maybe that's a possibility for compensating. So that labor, that instead of going out there every couple of weeks and controlling weeds, that weed pressure is not near as severe when you've got this nice cover crop bed there. And instead, resources can be allocated towards other things. You can have maybe even a larger operation. And so that was the big thesis behind this research project: is can we, one, successfully have a cover crop that we use as a mulch in a vegetable system, and can we see surrounding benefits? So we did this replicated on different research blocks. So we tried to repeat this experiment as much as we could. So we made sure we were collecting the best amount of data as possible. And we had a Merced rye, so it's a cereal rye that was our cover crop, along with a field pea. And we chose a mix because when you're trying to get something out of your cover crop, whatever seeds you're putting in, you want it to match what you're trying to get out of it. And we chose rye because that's a grass that puts out an incredible amount of biomass. As you saw from that video, we had a lot of coverage. And it also is something that puts out a really nice root system. So a big part of what we're trying to do is in these beds that have this cover crop over top of it, we're trying to have really nice structure of the soil. And we wanted to create as good of an environment for our vegetable crops to grow as possible. And that is why field peas were also added to that mix, them being a legume. So if you're not familiar, the legumes have the ability to fix nitrogen due to the symbiotic relationships they grow with the arbuscular mycorrhizal fungi, which is a lot of words just to say the microbes that are able to work with the root system of these legumes and create their own set of fertilizers. So it's, instead of purchasing and applying a synthetic fertilizer or even an organic fertilizer, which can be very expensive, we wanted to see in a low input system such as this, could we get that same benefit of fertility just from the cover crops that we put in? So we have these cover crop beds, and we have them contrasted with a control. And these are our conventional organic beds. I'll call them the bare soil beds throughout the talk because they are right next to our cover crop blocks, but they are right before we wanted to start the experiment. We did the tillage compared to what a conventional organic grower might be. We made the beds so it was just bare soil and there wasn't anything growing when we transplanted our vegetables. And then we wanted to measure what kind of a difference in all aspects of the weed pressure, the soil fertility, the production of these vegetables in that bare soil treatment compared to the cover crops. And we selected a couple different vegetables. We had a yellow zucchini squash, a bell pepper, and a eggplant cultivar that we had repeated in each of our blocks had these, and we chose these because they represent a fast, medium, and slow growing vegetable. The squash is something that if you have any familiarity with growing one, and even in your garden, you can put in a transplant, and within a couple of weeks, you're already starting to be able to harvest small little zucchini compared to an eggplant that's several months before you're able to start harvesting it, and the pepper being in the middle. So the idea is there any difference if we're able to identify any benefit or maybe some challenges with growing vegetables under a cover crop system? Is there any difference in a vegetable that grows really fast and is able to produce really fast versus one that's going to have a long investment and you're going to have to take a while for during the production system for that vegetable to grow? We wanted to see if those benefits persist. And so the data that I'm going to show you is a lot of it is taken from both years of this experiment. So the first year was in 2023, and most of that stuff's already been analyzed and I'm able to show you. But we repeated this experiment in 2024. So some of the harvest is just finishing up, and then there's a lot of other data sets that are still works in progress. But I still have a lot of really great information to share with our findings from this system. Now, the first big question where we come from a starting point with this project is, can this cover crop mulch, this mat of dried cover crop, provide a barrier to weeds? And on this kind of ground where during the growth season, which in both years we transplanted these vegetables in early summer, there in this part of California, there is absolutely no rainfall. So any amount of irrigation or moisture that these plants are going to get is entirely reliant on drip irrigation, which you can see those images. And anywhere you put in irrigation, you're going to get a massive weeds coming up. And that's what you can see on that left-hand side. This is a snapshot of one of those bare soil beds where if you strain really hard, maybe you can see the vegetables growing in there. But as you can see, it's incredibly challenging and requires pretty meticulous management of these beds under this system. And we, after collecting data and taking some of these pictures, we would go through and dedicate resources to cleaning up the beds. Otherwise, we would have no vegetables. But we're also trying to keep track of what kind of a time investment it would take to manage weeds in that system, contrasting that to the image on the right-hand side where this is taken the same day, just a couple feet down on the other research block, where you see the cover crop residue does an excellent job suppressing weeds. And this isn't to say it was 100%. There is going to be some weeds coming up, especially the vine weeds or some of the more viney ones that don't have a really large starting point. They're able to shoot through and wind their way through the cover crop residue, but it was a significant difference. And that's what I'm showing you here. So I try to keep throughout this talk the motif. If you see a brown bar, that's the bare soil. So that's conventional organic control that I have where there was no cover crop, and the green bars are the beds that were under the cover crop. And so I've kind of got it broken down where we, at several time points throughout the last 2 years, where we collected the number of weeds in a set area, but also the amount of cover crop residue. So when I would take my measurement. I also cut all of the dried cover crop residue that I had growing in that field, and I wanted to measure that. So after certain time points, how much of that residue is sticking around. And on the, so starting left to right, you see this was a couple weeks after we transplanted the vegetables, where we saw already those early weeds were coming up in those bare soils. There wasn't weed free, but it was already significantly less in those cover crop beds. And this is the amount of that dried cover crop mulch, excuse me. And as you could imagine, since there was no cover crops planted in that bare soil beds, there's no weight or no cover crop residue on those bare soil beds, but there's a pretty significant amount of that dry plant material on those cover crop beds. And at the end of that year's data collection, so towards December, we wanted to look at it again, and we saw a pretty significant amount of weed pressure. Despite routine management of weeds, they were still able to go up, where that weed pressure in those cover crop beds remained pretty consistently low. And we weren't exactly sure how much of that cover crop residue would break down or wash away, or how much it would still be on those beds, but a significant portion stuck around there. And for 2024, this year, this is data that I only have the July data collection, but it shows much of the same. We had actually greater weed biomass on those bare soil beds, and we had a little bit better average cover crop residue on the soil surface. So for 2 years of doing this, we were able to see consistently we're suppressing weeds by the use of these cover crop beds. But ultimately, the crop performance is going to determine whether it's going to be adopted. We can suppress weeds all we want, but if these vegetables aren't going to be happy, we're not going to see much going on. So I wanted to show, this is just the proportion of the transplants that succeeded. So the number of the vegetables when we put them in, following up about a month and a half later, how many of those vegetables didn't die for whatever reason. We saw not a lot of difference among our vegetables. The only one is the eggplant that we saw, and that's something that I'll address a little bit later on. And that was 2023, and this is 2024, where it's a lot of the same story. We saw pretty good success in both our cover crop and bare soil beds. And this was important because I wanted to make sure that this microenvironment that those cover crops were creating weren't going to be smothering or causing any adverse effect to our vegetable transplants. And what we saw is really good success. And in fact, any of the times where we saw them missing was when a particularly problematic rodent, whether it be a ground squirrel or a mole, was traveling around and knocking out some of our transplants. So not without challenges, but we're really happy with how they looked. And I'm now moving on to the yield. I want to go each vegetable that we said. So this is the yield of those yellow squash. And again, this is the one that was the fastest growing. So this was one that the plants grew faster, and we were able to start harvesting within 4 to 5 weeks. And this is the data that I'm showing you is the combined yield collected from these yellow zucchini squash from 10 consecutive weeks. So we did a very deliberate job trying to get as much yield from these plants as possible to see if there was any sort of lingering effect, that maybe one would have a boost early on and then decline rapidly, or vice versa. And so this might be a little bit longer of a window than a commercial farmer might be producing, but as I said, we wanted to be thorough. And what was really cool is, again, brown bars being the bare soil beds, green being the ones with cover crops. And the two experimental years, one theme that we see across the board is there is a consistent, better performance in those cover crop beds, which was really cool to see. So, the growth was driven by those cover crop zucchini plants producing yield faster. I was able to routinely collect squash from those plants 1 to 2 weeks earlier. And so during that window period, I was able to collect more, and they were routinely producing more fruit throughout the growing season. It wasn't that it jumped up ahead and then declined. It was maintaining a pretty impressive production and getting more than 20 different zucchini plants that I was able to harvest from each of those plants. So really promised with those results. This is the moving on to the bell peppers. And so this is the pepper plant. On the left-hand side is the bare soil bed. So you can see that it's not without challenges from the weeds growing around, but if you see, there's a lot of evidence of feeding from insect damage on the plants. And that's the same on the right-hand side. That's in the cover crop bed. It's a much larger plant, but again, not without its challenges. And this is where, for me personally, as an entomologist, this was a bit of a humbling experience. So I've dealt with pest management and a lot of other crops in the past. However, when growing these bell peppers, I was not expecting the small brown weevil that you can see there, which is the pepper weevil. And this can be a really devastating pest in both conventional and organic pepper production, because it's not the adult that's the challenge, it's the larva. So this female weevil will find a small pepper, one that's maybe the size, about half the size of a golf ball, that as it's developing, she will lay her egg into that pepper skin. And if you open up that pepper as it is growing, you would see probably an unpleasant look inside where it's being chewed on and rotting from the inside. And what you can see here is a couple of the pepper weevil larvae. So they're growing from the inside, eating it, and the plant can get feedback that this fruit is being fed on the inside, that it's not growing the way it does, and the pepper plant will drop those fruit. And so you won't see the pepper on that good size that you're imagining. Instead, you'll see the furrow of all your beds filled with golf ball sized pepper plants that were stressed and dropped. And because of this, unfortunately, by the time I was able to catch wind of it and start trying to manage it, the pest population was there, and it resulted in absolutely no harvestable yield in 2023, which I had to sit with and kind of take that humble pie over the winter. But I went into 2024 really trying to manage it. And so through a combination of integrated pest management strategies, using pheromone lures to intercept some of the weevils and monitor them, using kaolin clay as a sprayable powder to make the foliage and the developing fruit a unsuitable place for the pepper weevils to lay their eggs, I was able to collect some data finally for 2024. And it's a really similar story. We were able to see really great yield. Again, this is just showing you the yield and just per weight of peppers we were able to collect per square meter area. So this is just a comparison between those brown bare soil beds to the green. And what you saw is a dramatically higher yield. In fact, it was over 8 times higher yield in those cover crop beds than the bare soil beds. It was driven by the growth of the pepper plant itself. In those bare soil beds, the plant maybe would put out 1 or 2 fruit throughout the entire growth season, but a lot of those plants that we were monitoring throughout the season, they just kind of reached a plateau of growth and put out very few, if any, buds that would turn into fruit. And finally, the eggplant. This was similarly about 6 weeks after we transplant, where those bare soil eggplants, it looks like maybe I transplanted them a few days ago instead of a few weeks ago, compared to, again, same day that I took these 2 pictures, just in those cover crop beds, where this plant, so much more plant material, and it's a little bit difficult to see, but it's even producing some buds already at this point. And this resulted in the eggplants being the most improved through the use of cover crop residue. That's showing me one of the particularly beefy eggplants, and this is the cultivar Rosa Bianca. So it's not quite the eggplants that you imagine you probably see at the grocery store. It's more of a pinkish whitish to some of those deep purple in color and stays more rounded, but we were able to have pretty significant yields, as you can see there. It's almost 2 kilograms per square meter in 2023, and a little bit less yield. But I do want to say I plan on doing one more harvest, so maybe that number in 2024 will bump up a little bit more. But you can barely see the bare soil bar in 2024. There was just, again, really challenging growth. If any of those eggplants even grew, and why, if you remember back when I was showing those graphs on the transplant success, the eggplants of all the vegetables had the hardest time there. As I said, they're really slow growing, and whether it be some sort of need that wasn't met from the soil quality, or being a little bit protected from that cover crop residue, they were just really almost never able to take off. In fact, in 2024, across all of our beds, across all of our bare soil replicates, I've so far only harvested 4 total eggplants compared to more than 140 eggplants from those cover crop beds. So it's really dramatic differences. And so I was really happy for the challenge with bell peppers in the first year aside. 2 consecutive years of really impressive differences in the yield between these 2 vegetable systems. And then we simultaneously, it's not just we planted them and we sat back and just waited till we could start to harvest. We were constantly, or not constantly, but we were routinely collecting other bits of data to try to get an idea of what is driving this. And one of the interesting aspects of what we saw is that little bit of a microclimate that cover crop residue was able to provide. Every week we would go out and with a soil probe in each of those beds look at the moisture and the temperature of all the beds, so you can see if there was any sort of difference. And I want to say there was no preferential treatment being given to those cover crop beds as far as irrigation and management goes. It was the same header line that provided water, that had hoses going throughout all the vegetables. So it was the same volume of water distributed across those beds, but it was how accessible that water was. A couple days after any sort of irrigation or irrigation event is when I would try to collect that bits of data, and it was routine that those cover crop beds had much higher moisture content. It averaged over 12% higher moisture throughout all the beds across all the times we took measurement, and they were always a little bit cooler. So any amount of stress they could feel from these hot days in California here, where the sun is right above and it's pretty intense, that extra stress might have been mitigated a little bit by having those cover crops creating a nice little environment. We also wanted to look at if there was any difference in the dedication of producing this cover crop, what it did towards the fertility and the quality of the soil. And so we took routine soil across the time period. So before the experiment started, we took soil samples across all the beds, and we wanted to get an idea of what is our baseline. So what kind of quality is the soil to start with? And then we were able to, in December, at the end of that experimental year, take soil samples from those same places and look at what those changes were. We did the same data collection in February of 2024 and will again at the end of 2024, but I just don't have that at a point to show you. So what I wanted to show you, though, is this our kind of first snapshot and real early picture at what kind of differences we saw last year from February till the end. And this is just the percent change between these systems from where it started to where it ended. And I highlighted a few that I found were particularly interesting. So things that are important if we're talking about building soil health, building soil that has a lot of fertility, and not just having a lot of microbes, but having a lot of diversity in those microbes. And that means that there's more things living there, there's more relationships that can be made, and a lot of these microbes that serve as a way to make whatever nutrients are available in the soil accessible to the vegetables growing. So what we saw is some really interesting things. In all cases, the microbially active carbon increased, but we saw more of a double percent increase in those cover crop soil beds compared to the bare soil. Things like organic nitrogen, which shows us that in both cases they decrease, so there maybe isn't enough nitrogen created from those legumes that we had growing that system. But what we saw is those cover crop beds had a small percent decrease compared to those bare soil beds. And the last one I want to highlight is soil health score, which is a composite score that puts in a bunch of different factors and generates a nice, easy number for us to look at, where the soil health score from February to December in those bare soil beds went down while it did go up in those cover crop beds. And that's something that following up and as we have a longer timeline, we can see, do these benefits or these differences that we see, do they kind of level off even after a second year under these practices, or are we able to see an additive effect in years after years of these regenerative practices? Are we able to see those benefits increase? And I talked a little bit about the challenges with irrigation, but I do want to point out that this might be a familiar scene no matter where you are, the fields flooding and the challenges that go in with that. The last couple springs in Southern California and a lot of California, it's been these very large rainfall events where over a day or two, there's an incredible amount of water that just totally saturates the soil, relies in flooding in the field. That can be challenging because, as I said, then in some vegetable operations, there's constantly vegetables being produced. And so this could be leading to diseases and rots and loss of some vegetable fields entirely, or by virtue of that standing water and mud, making it really hazardous and unsafe for farm workers or any sort of equipment to be working in the field. And so creating a structure and a quality of soil that allows, whenever in a rainfall event like this happens, a greater portion of that is able to be infiltrated into the soil, and at that point it's in the groundwater. It can be accessible to the vegetable plants if they can put down roots deep enough. So in those months, when there's no chance of any sort of precipitation for months and months, there's still, if you go down deep enough, some moisture in that soil. And what we do to kind of tease at this question is using a water infiltration test. So it's an aluminum ring pounded in the soil, and you simulate, so you have a set amount of water that's 1 inch for that set area with the inside of that aluminum ring. You pour it in, you can record how long does it take for that water that's in there to totally be infiltrated and leave that soil surface. And what I'll be showing you is the second round of doing this, because you do it to get the best data you can. You do it twice. The first inch of the rain that you're putting in there to saturate the soil, so to kind of get all of the samples at a standardized level of moisture. And that first one, or that second inch that you put in, so it's already very saturated soil, you put in this second inch of water. So how quick does that already saturated soil allow water to be infiltrated in? And what is really cool is that this was taken about halfway through the vegetable growing season. So it was about late August, early September. And in both years, and this was repeated a bunch of different times, we saw that the infiltration time, so the time for that water to leave the soil surface, took significantly longer in those bare soil blocks. And so when you've got that cover crop residue, and I should say we didn't just put it on top of that residue. In the case when we were doing this test, we would move the residue to the side, so it was just that soil, just again, not trying to stack the deck in the favor of these cover crop beds. And what this shows is that if this was during a season where we get some sort of rainfall, a greater proportion of that rainfall that we get is going to be quickly infiltrated in the soil, not sit there as standing water, be evaporated, or leave your field as runoff. Or anytime you're choosing to irrigate throughout the growing season, again, a greater portion of that water is more efficiently taken in by the soil that you're putting out there. So I do, as I said, I mentioned I'm a entomologist, and so throughout the growing season, I'm taking a lot of data on different aspects of pests and beneficial insects that we're seeing in this field. And I don't want to make it seem, as you saw in some, seem like it's free of insect feeding. As you saw in some examples, I had challenges with a very specific pest to one of the crops, the pepper weevil, but there's no shortage of things that are chewing or stressing out the plants. This image on the far left is a leaf covered in aphids, but if you have any experience with managing aphid pressure, that you'll see it might be a little challenging, but the aphids that are a bit lighter in color and look a little bit bigger, those are actually aphids that have been parasitized. So there are really small wasps that are flying around, these parasitoid wasps that sting the aphid, lay an egg inside of it, and much like the movie Alien, eat that aphid from the inside and coming out. So we've got this incredible diversity of natural pest control or beneficial insects that we are able to take advantage of by virtue of being at the McGrath farm that has been organic for years and years. And so where our research trials are, you could go hundreds of feet in any direction, and you're on agricultural landscape that has historically been free of all these stressors to insects. So we have, while there are some challenges with pests, there's this incredible pool of beneficial insects, things like these parasitoid wasps, lady beetles that do a great job on chowing down on our insects. And one piece of data that we've collected are the arthropods of the insects that are crawling on the soil surface. So as you might imagine, life can be challenging for an insect. Everyone wants to eat you. And so what I wanted to see is, can we, by putting that cover crop mulch there, are you creating an environment where insects are more happy to live there? They're able to crawl around and do a better job. And so what I've got here is just showing some of the beneficial groups, the isopods of those roly-poly, if you might be more familiar with. They can be really important detritivores, breaking down plant material, and their frass or poop is a form that can be really excellent fertilizer for plants. And then things like spiders, while they might be not be our favorite thing to be in the house, they can be incredible insect predators. Predators of pests, where we saw significantly more in these traps, which these traps are just a hole that was dug in each of the beds with a red Solo cup stuck in there. And any critter that's crawling on the soil surface, fall in, I can routinely look inside the cup, count the number of insects, toss them back into the field, and set it back up. And the last group are carabids. So those are the ground beetles, so those little black or brown shiny beetles that are, depending on the species, either really excellent consumers of insect pests, but a lot of them are also really great weed seed eaters. The problem with weed seeds is a lot of them are incredibly tiny, and there's thousands and thousands of them, and these insects are really good granivores. They're really good at eating lots of weed seeds, and so they might be doing a natural herbicide service without us even knowing it. So this is just a one of the bits of data. I'm also looking at what kind of insects are pollinating our different vegetable crops, along with what kind of insect pests are we seeing, and is there any sort of difference throughout the growing season. That are big pieces of data that once this field season wraps up, I'm hopefully going to be able to combine in one really nice story that our team out here will be able to put out as scientific articles and information that we share internally on Rodale's website. And speaking of the Rodale's website, I do want to make sure I give lots of time for folks to ask questions, but if you are interested in the stuff that I'm talking about, and if you are within a reasonable distance from the center, I would very much recommend that you come out and take a visit. So we have a running tour that we have set up. It's the third Friday of every month, and if you'd like, if you're on a computer, you got a phone handy, that QR code. I'll stay on this page for a little while. Is a will directly take you to the page where you can register for this event. It's free. We have people register just for the sake of allowing us to keep track of stuff. And I've got my contact information at any point. If you just happen to be driving through Southern California, but not on the third Friday, we're more than happy to accommodate with meeting you out in the field and giving you an infield version of the talk that I gave. But at this point, I will try to see if I can open up that Q&A session, and I will try to dedicate some of the time that we have for questions. And I really appreciate folks asking. The first question here, I'll try to go through. Were these direct seeded or transplanted into the crimped cover crop beds? So that all of these vegetables were done as transplants. So that's an additional challenge for some of these crops that you need to direct seed, but there are specialized implements. Some of these no-till planters and no-till transplanters that have special little shovels or implements that, by virtue of what they are, do a really good job to slice through that residue. But in this case, this is our first real challenge of it. So we just had flats of transplants that we just with a soil knife cut through the residue, stuck it in the vegetables, and did it along there. But the cover crops themselves were, of course, direct seeded. We just did with a seed spreader by hand. I don't think I said that specifically. The next question: could this research be conducted with native species instead of cereal rye? And I think native species, depending on where you are, is a great option. We in this set of project, one of our biggest concerns was our ability to, within a relatively tight time window, we had a good idea how long it would take for the rye to grow, and then we had pretty high confidence that we would be able to effectively terminate it with a roller crimper. But there's other cover crops that we use in the past, things like vetch, which is a different legume that can be kind of viney. We've had, or something like sorghum Sudan grass, that's a very robust grass that can grow. And those are much more challenging to terminate using the roller crimper. So if it all depends on what you're trying to get out of it. In this case, we were trying to relatively quickly grow a cover crop that could be easily terminated and used as a mulch. But if you are, it's a field that's been fallow for a certain period of time, and you're trying to build up its soil fertility, or you're trying to just add organic matter to it, a maybe mix of cover crop seed that you can get from a lot of different local sources probably could meet those needs better. But depending on where you are, I'm sure a combination or a selection of native plants could do the same job. If you had to only choose between an invasive cover crop and bare soil, what would be the better option? So in this case, it's a non-native plant. It's a cultivar that's been bred to be used around this region, and it's one that we had, as I was saying before, we had the confidence that we could terminate it. But I would say it just depends on what you mean by invasive. Invasive is the one that's in the county that is considered a noxious weed or something that is described as problematic. Where we are here, there's a lot of wild mustards that grow in natural or semi-natural areas, and so those can have a lot of benefits. They have a lot of biofumigant properties. They put out a really nice root system, but I would, in that case, something that is very problematic in a lot of adjacent areas, a mustard like that wouldn't be something that I would recommend. But I think in a lot of these cases, and I've had communications with growers and seeing a variety of different options. There's some growers that instead they just rely on the variety of agricultural weeds that grow in their field, and they just use those as their source of organic matter. So I think if you're trying to really have a set of regenerative practices, and I think if you've got something living, if you've got something that's putting in living roots in the soil, that's aiding towards creating good soil structure, that's creating relationships with microbes, I think that's, from the perspective of soil health, that's better than just bare soil beds that you are routinely tilling up and not giving a good chance to have any sort of real structure. So the next question, the IPM tools for the pepper weevil. I did breeze through those pretty quickly, so I apologize. So it was the couple of things. So I purchased a pheromone lure. So it's a smell that the male pepper weevils find irresistible, and I put that right on top of a yellow sticky trap. So just the sticky traps that you'll see in greenhouses or wherever to catch insects. And so that was a bit of a monitoring tool. It wasn't that every weevil coming in was intercepted, but I was able to check that and see, okay, no weevils yet. And when I start to see them on the trap, that's when I know I need to start being on the lookout. And it was a kaolin clay, Kaolin. I always do that because it was a mixture that was recommended. It's buy as a powder. I just mix it in a small backpack sprayer with water and applied it, and so it covers it in kind of a white dust or film. And I had it was something to try, especially considering I had no success in the year previous. And it wasn't that we were totally free. I would still see some peppers falling off, but it did a much better job on just the fewer eggs were being laid. And again, one of the practices that I didn't mention at the time, I believe, is just basic field sanitation. So I was much more proactive as soon as I saw peppers dropping. So if a pepper drops, that the plant aborts it, that means that inside that really small pepper plant, there's either a larva or a pupa or maybe even an adult of that pepper weevil in there. So I'm routinely picking them up and destroying those abandoned fruit. So that way, if I left it just sitting in the field, then that adult would crawl out and, hey, she's right in a pepper field already where she can just jump to the next one. So I'm trying to break that life cycle as much as I can as well. So those were the main practices that I used. On top of just every week, I was walking through and looking. Those, as you can imagine, a weevil that small is hard to notice crawling around a plant, but noticing physical holes or dimples in the fruit on top of the fruit being falling down, and routinely scouting and knowing what was going on in those fields, I think was the most productive. Are the yields from plants grown in bare soil comparable to yields from the same plants grown by conventional farming? So I would say no, because in a conventional large-scale operation where the grower would be reliant on producing as much yield as possible because that yield they're selling as profit. There would be more of a fertilization program. If in a even in a conventional organic system, they would be applying some sort of fertilizer, whether it be fertigation through the water, some sort of organic granular fertilizer, compost, some form of fertility. But we were not trying to add a lot of confounding effects to it. Like in the same way, if you hear someone from a university or any sort of research trial, you talk about you're trying to eliminate all these extra factors that could change the aspect of one thing or the other. So we were trying to, in this case, have a really low input system, or in some cases, no input system, where we were trying to see um, without any sort of extra fertilization added to it, was the amount of was the cover crop able to provide any sort of nutritional benefit. And so a more fair comparison would be to compare it to bump it up to what a conventional grower standard would be adding some sort of fertilizer program, which, as I said, for the sake of creating a nice, clean experiment, we chose not to do. So this question is centered around, I've heard about very diverse cover crops, numerous species from different families that create diverse microbial life, which creates resilience through drought and flood. Could you try this method of cover cropping? Um, yes, and so in more demo plots or some of the other areas around here, we've done more diverse mixes um, because and there's you can reach a plateau to it, but I would say as a rule of thumb, the more different plants that make up your cover crop mix, the more unique depths of the roots, the more unique structure of the roots, and that's going to create more diverse and unique interactions in communities, microbes that can do all sorts of things, including drought relief, and part of that being different plants having different roots, some of them going very deep down that would do an excellent job in helping with water infiltration. Um, and that's down the road. This is by no means this project that I'm talking about the where it's going to end for us. We're going to keep trying these sort of practices, and we want to really be able to show a consistent that we can do these cover crops with these vegetables, but we want to keep expanding different cover crops. We want to expand for us, as I mentioned that map. There's a lot of strawberries grown in this area, almost all of them grown under plastic mulch. And so can a nice mat of cover crops replace that plastic? And so that's another bit of low hanging fruit. And wow. So without meaning to, the next question, were there any comparisons to the use of plastic mulch? They're saying that there's a lot of farms in the area using it rather than the bare soil, and that's absolutely the case. As I just unintentionally mentioned, strawberries and a lot of the vegetables that are a bit longer. Just my own experience driving around the county, a lot of the pepper fields I see use the black plastic mulch that is used in part as a weed barrier that no weeds can grow through, so it helps instead control that. But those can have a lot of negative effects on compaction. They're, by virtue of nothing else growing, that can be really hard on the structure of your soil. There's a lot of tillage that goes into making those beds and getting it to a right consistency to roll that plastic over it. And then when that season's over, that's a lot of plastic waste. And there's in the agricultural community out here, there's a huge portion of plastic waste. And that's not to say the growing awareness and concern about the what those break down into, the microplastics that are routinely found in every soil sample that are collected from out here. For this experiment, we chose to do that bare soil to the cover crop, but a future experiment I think would be really interesting to look, have it be a, and we've done that in the past. A totally different talk that our group out here has done is the same kind of question, but it on strawberries, but instead of a bare soil control. It was a plastic mulch control compared to cover crop residue, compared to a few living mulches. And yeah, we're trying to see what are growers doing. Is for a certain crop, is a lot of it under plastic? Is a lot of it just bare soil with a lot of heavy tillage? What are the practices, and where can we find some creative, more sustainable solutions to it? This question, this is a great question. The length of time between the termination of rye and the transplant of the seedlings, I think I probably didn't say it. It was about 4 to 5 weeks. Is the timing that we use. And that was just it probably could have been a little bit earlier, but it's when you're okay, this is how the cover crop's growing, and this is when we think it's going to need to be terminated, because you don't want to wait too long to terminate it, because you don't want those seed heads on the rye to fill out, and then when you terminate it, it's going to drop them. Then you've got all that new rye regrowing, which is just as problematic as weeds growing in there. And so balancing that with the growth of the transplants, we didn't want to put them in when they were too feeble and wimpy. We wanted a good transplant they were happy with. So if you're the more we do it, the more we get a better gauge on those timing things. We can adjust a little bit more or less. But that is all that. Let me see. I know there's a couple. If there's anything else in the chat, I can. The only one that I see in the chat unique is what would best intercrop besides tomatoes. I guess I'm not sure what you mean by that. I think the one, there's some certain cover crops might have some allelopathic effects, and by that means that the as those cover crop residues break down, they can be instead of helpful, they can be stressful to the developing seeds of certain vegetables. But for me, when we're trying to kind of meet this match, find a blending of cover crops and a blend of vegetables to find a good fit, I don't have that wealth of knowledge in my head, so it ends up being a lot of, for lack of a better word, homework on the back and looking at previous trials, and there's no shortage of resources, looking at what are good fits, and just the same as you, looking at online resources to find those practices the best I can. So I want to if there's no other questions, I think we can drop it off here. I do want to thank folks one more time for taking attendance, and again, if provide my contact info there, so feel free to reach out at any point, and if you're ambitious enough, come out and take a visit. And once again, thank you for joining this talk.